You download the absolute best open source model on the planet. You load it into your local machine. You ask it a complex question involving a massive codebase. The graphics card fans start screaming. Suddenly, the terminal throws an out-of-memory error. The entire system locks up and crashes. It makes zero sense. You have 24 gigabytes of video RAM. The model weights only take up 12. Where did the other 12 gigabytes go? Why does a state-of-the-art graphics card fail on a simple prompt? The answer is the KV cache. It is the hidden bottleneck slowly destroying local artificial intelligence. Every single token the model generates requires holding the entire past conversation in active memory. For a 10,000-word document, that memory footprint expands exponentially. It eats your hardware alive. It is incredibly frustrating. We have these massive reasoning engines, but they are trapped inside a hardware prison. And the industry trend is making this infinitely worse. Context windows are growing exponentially. Models now accept 1 million, or even 2 million tokens. The math on that is absolutely terrifying. To hold a 1 million token context window, a standard model requires nearly 800 gigabytes of RAM. That is not a consumer computer. That is $1 million data center cluster. Developers are being priced out of their own field. If you cannot afford cloud APIs, you simply cannot compute. Listen to what a prominent open source researcher recently stated on a forum.
We are hitting a physical ceiling. The models are smart enough, but the memory architecture is completely broken.
People are resorting to extreme quantization. They are crushing the models down so far that they become stupid. We are sacrificing all the intelligence just to make the file fit on a hard drive. But this week, Google researchers unveiled something that breaks this barrier completely. They call it TurboQuant. It is an algorithmic breakthrough specifically targeting the KV cache. Instead of keeping the entire context in high precision, TurboQuant compresses the memory dynamically. It identifies which tokens are mathematically important, and drastically compresses the ones that do not matter. The results are staggering. It reduces the memory footprint of the context window by a massive factor. A massive model that previously required multiple expensive graphics cards can now run perfectly on a single consumer GPU. This is the holy grail for local artificial intelligence. It decouples context length from memory requirements. You can now dump entire repositories, 10 books, or a massive codebase into your local model. And the graphics card will barely break a sweat. It just works, silently and instantly. The lead engineer on the paper summarized the impact beautifully.
We have solved the memory bottleneck. The future of AI is not in the cloud, it is on the edge.
This changes the power dynamic of the entire industry. Open source models can finally stretch their legs. If you have a mid-range laptop, you now possess the analytical power of a supercomputer. The cloud monopoly is officially under threat. Prepare your local environments. Because true, unrestricted, agentic AI is finally coming directly to your desktop.